Hello everybody. Today we're finishing the Watz reactor with its final machinery. It needs some auxiliary machines. Notably, we're going to need to do the steam loop, but I think it's basically done, which is exciting because, I mean, we've put a lot of engineering, a lot of time into this to make this happen, and, I mean, it's been a good run, hasn't it? We've finally finished this machine. So next up, what you can expect to see in the future is the next machine after this thing, which is going to be the cyclotron, which we do need the cyclotron, believe it or not, for some future objectives. It turns out cyclotron is important for those. Making antimatter is important as well, notably. So, let's set this guy to coolant. How much coolant we got in there? This can hold 3,200, can it? Oh, right. So we already have enough once this is done. You don't need 48, you need 32. What? What is this? Okay. Well, once it's done, it's done. It's done. Okay. So we have 24 left over. So you needed 24. There is one more piece of this machine that you need to do before you can make all of these centrifuges run, which is the actual speed upgrade for the centrifuge, which we'll be able to make 4 of those, no problem. And that's the last thing I'm going to do before we get this thing running. But first, we need to get those turbines, because that's going to be the hardest part. We also need to get the coolant back and forth, and a solidifier. The solidifier is for making CMB steel, which is something that we're going to want a lot of. So, and considering how this is set up, I'm going to have to do it like something like this to get to the solidifier, which is, we also need to power all these. Okay, I'll take care of that in a bit. We should have enough technetium to make another one of those condensers, although, would it really be worth making another one of those condensers, dude? The amount of condensers we made is kind of a lot. Like, actually, well, actually, it is worth it. Every time it's way cheaper than just building those other type of condensers. Maybe we might want to make that. I don't know. This is the last of the coolant it needs for this thing. You might want to take a tank and add it to this thing so you have a coolant buffer if you're weird. But I don't need that because I know what I'm doing. So this will basically turn coolant into hot coolant, and if this thing is going fast enough, then all of that will come out over to here. Now it's time to go make a big turbine. Whatever. I don't even. Should we go for the Leviathan turbine, or is it even worth it? I don't know. Because there's not even much space in there. There's not much space. We might just want to go for the regular turbines. Dang it. Yeah, no, I'm not building more of those. I've done enough of them. I've done enough of those, okay? I'm not building more Leviathan turbines today. Not today, okay. We're done with those. Now let's find the regular steam turbines, because I haven't built one of them in a while, and I really want to build one. I'll build the regular condenser today as well. Well, not the regular one, the electric condenser today. Because that's what I'll do instead of building a Leviathan steam turbine. It's either I build a Leviathan steam... I actually would have to build both. Either way, it wouldn't really make a difference. There's a turbine. So we need 12 steel... Oh, I can do a bunch of these. Let's do this. We're going to need several of them anyway. 36 steel plates, right? Am I correct? Is it 36 steel plates? Yeah, it's steel plates. And then it's rubber bars. Then it's, after that, titanium steam turbine, which we can do. Let's make those steel plates first. There we go. Those are the steel plates. Done. Now, what about the condenser? What does that need as far as okay, technetium steel? It needs quite a few of them. It needs 4 welded technetium steel plates, which in total adds up to 24 technetium steel cast. Well, not 24 technetium steel ingots. That's what it is. We should have the stuff for that over here. If we have the stuff, that is. We have 32. Okay, that is... How the heck are we doing so good on this? I'm out of... Actually, I'm definitely not. I have none left. We're not able to make any more technetium for the foreseeable future. Well, I mean, anything with technetium for today's episodes, I guess. That's what I'm trying to say. Come on. Okay, now let's run this through here and start making those. Because we're going to need to make that. if we want to make the rest of stuff. Alright, so each turbine will cost us a total of... how many would that be even? I don't even know. Okay, each blade costs 24, doesn't it? Let's go ahead and try it. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oh, okay, we're gonna need 24 times 3, which is 30 plus 12, 42. I think. No, it's wrong. It's wrong. It's 60. But because it's what is the 60, and then something. Because you take the 24 times 3, you get 60. Then the 4 times 3, you get 12. So it's 72. I think, yeah, 72. Okay, well, I need to do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That'll give us 42. 10 more. Oh, yes. Just love making these turbines. But this is the easiest part. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those should do, because it's practically a 1-to-1 ratio of how many turbine blades you get. So then it gives you 5, and then 8 plus 64 is 72. That's the turbine blades. Oh crap, we need high-speed steel, and we're all out of that, basically. So we only have enough, if we split this down, we have enough for all 3 of them. What a miracle. That's actually a miracle. I don't have to make any high-speed steel in today's episode. The thing that might be difficult is these integrated circuit boards. Although I think we have a bunch of them, I'm not sure. Screwdriver, the cast plate out there, shove in like 9 of these guys. Wait a second, I just shoved in 6 of them, didn't I? Got 5 ingots left in there, which is not enough, because you need 6 for each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. That is how many you actually need, is 12 of them. Now, let's go ahead and mine this. And put it back in our inventory. Let's go ahead and make those turbine blades. We need to take some of these guys and some of these guys out. Let's make these turbine blades now. We're going to wrap this guy, and this is going to be our first turbine blade. 1. 9. There we go. We're done. Perfect. Perfect. Awesome. What I like to see. Titanium steam turbine blade. We now need 3 high-speed steel pipes for each one. To make high-speed steel pipes, we're just going to take these, take them, turn them into those. And to make the short ones, it costs 3. To make the big ones, it costs 4. But in this case, we're only making the short ones. Now it's time for the steel pipes, which are the worst of the worst. 48 of those. How do I know this? Because I'm just guessing that it's going to divide down into 12. Because we need 4 times 3. I mean, hey, this could be worse. Steel. We're short because it made a different amount than what I need. But we're only short 3 of them. So we need to make 9, and then I need to type in steel again. Come on, make the steel. Now, do it. Perfect. Okay, that's amazing. And now I take this down to here. Do this. Do this. Circuits. Where the heck are the circuits, dude? Now this is the cheapest part of making these things, is circuitry. Let's get started on them circuits. Start cooking. Problem. Circuits are gonna cost a bunch more gold. And I don't happen to have a bunch more gold left. Well, actually, I have a bunch of gold left. Well, actually, not in my inventory, though. It's in my crate. Which sucks. Oh, bear in mind that I'm going to finish this today. So, if this episode ends up being 30 minutes long, then I guess you all get an extra long episode. But I hope that's not the case, because I'm trying to keep this relatively within what I like to consider the golden amount, which I don't even know what that even means, so let's just shut up. Let's go ahead and do this. Perfect. Got those. Got these. Now, if I take these and slap these with those, then some weird stuff will happen and I get printed circuit boards, which, I mean, there's no phenolic juices or anything in there. What are these? These are phenolic circuit boards, correct? I assume these are phenolic circuit boards. They're integrated circuit boards. I mean, grid thick. 18 dense gold wires. Shove them in there. Cook them up. Fry them. Oh yeah. This is the frying machine, not the assembly machine. Or you could call it the crying machine. I don't know. You take your pick. Okay. One more. We just made 3 steam turbines. Like, what the heck? Instead of just making one big Leviathan turbine. I mean, these guys, you could probably make like 100 of these guys in the cost of one of these. So, I mean, they don't even cost the same stuff, though. That's the thing. Well, they cost some of the same stuff, but, no. Well, how much does this guy cost anyway? He costs, like... He's just a slightly bigger version of these guys. But also, he's only 85% efficient. Oh, whereas these guys are 100%. So that's why there's an advantage in using these guys for the Watz reactor. Because we're only going to run steam. A. And B. Why not? Why not? Ladies and gentlemen, it's a rainstorm. Let's go. Let's go ahead and set this stuff up. Let's get cooking. Or be cooked. No, that's actually messed up. Shut up. Yes. So let's set up these just stack of turbines. Stack of turbines. I'm not sure how much that looks cool. Let's just put the turbines in the other room in case it explodes. That's right. Turbine safety 101. You want to keep your turbines safe? Don't leave them exposed. That's rule number 1 of turbine safety. Keep them safe. Keep them blocked. Don't leave them exposed. Otherwise, you're going to have some bad stuff happen to them. They're going to be explodicated, destroyed, destructified. You don't want those things to happen because you don't have turbine insurance. Or you can just hire me as your turbine insurance agent. Pay me $24 and your turbines will be perfectly safe. Trust me, bro. Trust me. Plus, on the other side of this building, there's a room that's on the exact same side. So, and it's a laser beam room. It's the laser tag room. Guys, that's the laser tag room. That is where we do laser tag. Well, we do laser tag for gravel and RBMK fuel chunks and stuff like that. Also, it looks cooler if you set it up like this. So, yeah, there you go. That's a reason to set this thing up like this. Because it looks cool. So, why not? So these are all going to be set to steam, with between them we will have these, which are going to be the low pressure steam ducts, and then on top of this, I guess, condenser will go on the other side of the room to look cool. Yeah, and also be functional and practical. So I mean, yeah, why not? Yes, low pressure steam, please. My favorite type of... Actually, that's my least favorite. I think my most favorite is steam that doesn't produce low pressure steam. Which is none of them. Well, I mean, some of them don't. But they all inevitably end up producing the steam that does produce that. So therefore, they're all bad. Condenser time! Oh yeah! It's that part of the episode where I build my 3rd electric condenser for no reason. You don't need 3 electric condensers. I'm not sure what you're doing if you have 3 of them. You must be insane. Or have 5 fusion reactors all running simultaneously. Which is actually messed up. You shouldn't be doing that, dude. You need to knock that off. So. Oh, yes. It's time to make another one of these. We're going to start with the 24 steel pipes. How do you make 24 steel pipes? Well, let me show you. You take the number and you multiply it by 3. Wait, what? Does that actually does work. But I already have 12. So I already know that I don't need. I need half of that. So I need 12 in each stack. Perfect, dude. You see that? That's math. You can actually just take 24, make 3 stack. Wait, what? I'm confused skin. Let's just shut up. 36 is the number for 12, and if you take 36 and you multiply it by, divide it by 3, you get 12. So, math. I love math. Ladies and gentlemen, we got 16 copper plates ready to go. Well, ingots to plates. It should be pretty easy. And also time for the last part, which is going to be the dash motors and the other stuff and things. Which we have the stuff for dash motors. Check it out. Watch me make motors in 5 seconds. Are you ready? No, you're not. Holy crap, we actually have the stuff for dash motors, except gold. Gold! Always don't have gold. And iron, because of course we can't forget iron. Our good friend iron is used in the production of everything. But I need 4 pieces of iron. Yep. And then I need 2 of these. Awesome. Shut up. Ah, yes. Do this. 1, 2. It is fusion reactor time. Awesome. This is what I've been waiting for a very long time. Actually, wait, no, what? It is not fusion reactor time. What? Dude. Fusion reactor's over there. We've already built the fusion reactor. It's not fusion reactor time. It's Watz reactor time. Weld up those darn technetium plates. Okay. Should be good. Let's go ahead and take care of this now. Boom. 2 of them. Time to make coils. Oh crap, I'm gonna need 2 more of these. Why? Why? Dude, I thought I had it today, but no, it seems like I don't. I need 2 more iron ingots and 2 more of the other things. Finally I finished these dash motors, which means now I can do stuff and things for the things, and just assemble this. You need the actual engine lubricant, of course. Let me grab the tanks from over at the place. Man, I'm very tired right now. Where the heck are these fusion reactor... not fusion reactor pieces, dude. These are steel tanks. Legitimately, I'm so tired I'm calling tanks fusion reactor pieces. These are not fusion reactor pieces at all. These are used... These aren't even used... Well, maybe they're used to get to the point where you can build one. What the heck is with my obsession with fusion reactors right now? This is a severe issue. Tiredness. I can only assume it's because I'm tired or something stupid. I'm not sure how this is happening. Okay. Also, I'm welding up the plates for the titanium and also the steel. So, both are happening right now. We're done. I just need to hook up one thing. That is the water barrel for the actual water loop. So there's 2 loops inside this reactor. There's the coolant loop, the water loop, and the baloney loop, or as I like to call it, the waste disposal system 5000, which we've already set up the baloney loop, we've already set up the coolant loop, we've got to set up this water loop. So once the condenser is installed, it will go over to here, and from here we'll have the low pressure steam go into here. Yes, that's how things are meant to go. So the water will go all the way through the system, come all the way back, do all its shenaniganery and stuff and things, and everything will be good. A-okay, 100%. Perfect. Hopefully. So this is the water loop. That's where I want the water to come out of, because the water is going to be basically in line with that. Then the water pipe will probably be right here. Oh, I'm short. Actually, I got all the pipes we need. Don't you worry. Got all of the pipes. Here's a steel tank set to water, and with the double output mode, so it will fill up this guy to his limit. Watz reactor fuel needs graphite for the actual... why is it balls? Why the heck are we using ball fuel? What? You know, I'm not gonna question these things. This is just a weird thing. 16. That's enough to make 8. Yep. That'll be welded in 5 seconds. Don't you worry. That will be done. Oh my gosh, we're done. We're done. First fuel I'm gonna run. Neptunium. Neptunium gives you technetium. Also, I'm noticing these cables. Mr. HBM, these are looking very good, these textures here. Are these new textures or something? They're very good. 2 more welds. I hate welding. In real life I tried to build a welding machine using a microwave oven. I took out the transformer component and I plugged it into the wall. Right. And it made the wall hum. And that was a long time ago. But this is why I no longer play with electricity. Because anytime I play with electricity, something goes wrong. Anytime I do anything, it usually goes wrong. So, what are we missing, dude? We've got our 24 steel pipes. We've got our engine lubricant. We've got everything, practically. What do you need, like, more steel or something? Well, let's see. Play. Dash motor, cadmium steel plate. Yeah. Dash motor. 3 dash motor. Oh, come on. Bro just extended the episode 5 minutes. Ugh. Should have done it right. Should have had this done. should have. But I just didn't. Because I didn't think that hard. Gah. I need 2 of these gold ingots turned to gold wires. We're gonna take the gold wires. Finally, just finish this rubbish. 2 of these. And, now that it's done, I'm done, dude. That's a dash motor right there if I've seen... that's a coil right there if I've ever seen one. Hold on. I gotta make the coils first. Hey, forget this thing. Finally. We can relax, guys. We finished. And now it's time to cook up. Is it 4? It's 3 of the shrebidium. 3... shrebidium thingies. Oh, there's more to this, though. I said I'm gonna need hoppers and crates, and that's what we're gonna make. And also, technically, a liquid solidification machine. We can just move the old one, can't we? But it's set up for the oil stuff, isn't it? Yeah. Well, let's take care of that thing, and then let's move it over, and then... You know what we're gonna do with the heating oil? We're gonna start dumping it! Goodbye, heating rubbish. Nobody needs you. Not even us. Alright, I got the hoppers, I got the solidification Matron 550. It's breach containment from the oil setup. Don't worry. Oh, come on, energy! Yeah, you all thought I was done. No, energy! It always ends this way, doesn't it? Bruh, I have to go all the way to the end to set these things into position. Holy crap. Got them all in. Right, so this guy is going to be hooked into the energy consumption line from, like, down here, I guess. Which actually would pretty much work. I think if I hook him in there, that'd be most efficient. This thing fits like a charm. I didn't expect it to fit so perfectly between these 2 pipes. I thought I'd have to do some shenaniganery or something. Energy is being supplied. I need energy to come back through the system. With this, I have the cabling done, which is actually one of the most painful parts, because look at it, look at this. Look at this cabling. Absolutely ludicrous. So much cabling. Shut up and get to work. This is the next thing we need, is the cabling. Well, not the cabling, the... Dude, it's happening again. It's happening again, dude. We need shrebidium ingots. So, the shrebidium Watz pellet depletes down, giving you 3 of those. Holy. Well, what about the Heinrich shrebidium? Well, not very many. So, keep in mind, you need to have quite a few of these on hand for making stuff. We are about to turn it on. The first thing I want to make sure of is that we have a lever. The second thing is that the coolant is cycling correctly, which is the first thing that might be a problem because we might have to switch these 2 pipes around because they might be wrong. Probably the only issue, hopefully. Let's go ahead and give it a shot. The coolant is cycling. It is running out of coolant very rapidly now. Very odd. Which this should produce the coolant, send it right back. Where's the coolant going, dude? Where's the coolant? You got... Oh, it's definitely because we got it wrong. See, that's what I mean. The coolant could potentially do that. So remember, check twice before you run. Right? You got that, right? You got the... Hold on a second. What is this? What is this? You're kidding me. This is not set to anything. It's set to coolant. What is this? Put this in here. Cook it. Right. Right. Wrong. Okay, it's running. It's running. It's got its water back. Alright, try it again. Coolant's good. Coolant's good. I repeat, coolant's good. How much steam are we producing? We're producing 2,000 steam, which is enough to run a steam turbine on that much. Steam is going through the system pretty well. It looks like each one's getting 2,000 steam, producing about, don't know, probably not even 100,000 kHg per tick. So, yep, that's one Watz reactor done. Now you'll notice we're building up poisonous mud as we run this thing, and that should be disposed of in this thing. But for some reason, it's not going to that thing for whatever reason. So let's turn that off and figure out why that is. My idea is that it has to come from the bottom of the reactor. So let's give this a shot. Now, shall we? Let's see if this is going to work. It could work, could not work. Usual thing. Let's see, mud. Poisonous. I said poisonous mud. Do it now. This should work. Yeah, it's going in. It went to the centrifuges. Alright, that's a Watz reactor. Look at it, it's not building up poisonous mud, isn't it? Disposed of. And let's see if the other system works, because, you know, we over-engineered this thing. We probably over-engineered it. Well, for this much. But when you start running all four of them, not over-engineered, it's actually necessary. Water is now at 15,000. It's not losing water. The coolant is staying at the same. The poisonous mud is staying at the same. The thermal units are going very high. We're cooking. Oh, there goes 4 centrifuges all at once. I love this thing. Awesome. Awesome. I need to set this guy to hot coolant. Perfect. What is this guy doing right here? Okay. So it looks like the system's pretty much safe. Well, will be relatively safe. And that's iron powder, and each one, it gives you the exact same thing. Awesome. Dude, I'll be stacking the crates. Well, thank you all for watching. We'll 100% be able to take this up a notch. Make it even more powerful with 12 of these. Although I'm not going to do that. See you all next time. Hopefully, I'll be running like 8 or something. Or a bunch of them. Maybe we could even do 12.